A flask that has a mass of 345.8 grams is filled with 225 mils of carbon tetrachloride. The mass of the flask in carbon tetrachloride is found to be 703.55 grams. Calculate the density in grams per mil and kilograms per liter. Density is the ratio of the mass over the volume. To find the mass of carbon tetrachloride, we must first subtract the mass of the flask from the combined mass of both the flask and carbon tetrachloride. The combined mass is 703.55 grams. The mass of the flask is 345.8 grams. Always remember to keep your decimal lined up. We'll bring down the 5, so we'll have to borrow from the 3. 15 minus 8 is 7. We'll have to borrow from the 70. This becomes 12, so 5 from 12 is 7. 4 from 9 is 5, and 3 from 6 is 3. And make sure you bring down your units. So the mass of carbon tetrachloride is 357.75 grams. Recall from the problem that we were given the volume of carbon tetrachloride. Now we have found the mass of carbon tetrachloride. We can then plug both of these numbers into the formula to determine the density of carbon tetrachloride. We will take 357.75 grams divided by 225 mils. We plug that into our calculator. We will get 1.59 grams per mil. You want to make sure that your answer has the correct number of significant figures. So the rule for division is that the number with the least amount of significant figures is used to determine how many sig figs will be present in the answer. And the mass had 5 sig figs, the volume had 3 sig figs. So therefore, that is why our quotient has 3 significant figures. We have found the density of carbon tetrachloride in grams per mil. Remember, the problem also states to calculate the density in kilograms per liter. We will convert the density of carbon tetrachloride in grams per mil to kilograms per liter. Starting with grams to kilograms, there are 1,000 grams in 1 kilogram, and the grams cancel, and we have kilograms on top, which is what we want. Next, we'll convert milliliters to liters, and there are 1,000 milliliters in 1 liter. The milliliters cancel, and we're left with liters on bottom, which is what we want for here. If you notice, you would divide by 1,000 and then multiply by 1,000. So actually, these would cancel out, and you'll be just left with the 1.59, but you'll be in the correct units, which is kilograms per liter. So 1.59 grams per mil is equal to 1.59 kilograms per liter. We have found the density of carbon tetrachloride in both grams per mil and kilograms per liter. Thanks for watching.